Hello everyone. Today, I will explain an interesting topic in graph theory called the crossing number of a graph. First, let's remember what a graph is. A graph is a collection of vertices, also called nodes, and edges that connect those vertices. Graphs are used to represent many real-world systems, such as road networks, social networks, communication systems, and computer networks. Now, imagine that we draw a graph on a piece of paper. Sometimes, two edges cross each other. These intersections are called crossings. In graph theory, we want to know how many crossings are truly necessary. This leads us to the concept of the crossing number. The crossing number of a graph is the minimum number of edge crossings possible when the graph is drawn on a plane. In other words, we can move the vertices and redraw the edges in different ways, but we always try to create a drawing with the fewest crossings possible. If a graph can be drawn without any crossings at all, then its crossing number is 0. Such graphs are called planar graphs. For example, a simple triangle or a square can easily be drawn without any edges crossing. Therefore, their crossing number is 0. However, not all graphs are planar. Some graphs are so complex that at least one crossing will always remain, no matter how carefully we draw them. A famous example is the graph called K5. K5 is a complete graph with 5 vertices, where every vertex is connected to every other vertex. Mathematically, it has 10 edges. When mathematicians try to draw K5 on a plane, they discover that it is impossible to avoid all crossings. The best drawing still contains one crossing. Therefore, the crossing number of K5 is 1. Another important example is K3, a complete bipartite graph. This graph also cannot be drawn without crossings, and its crossing number is 1. Why is the crossing number important? In practical applications, minimizing crossings can make diagrams easier to understand. For example, engineers use graph theory when designing electronic circuits. Too many wire crossings can make circuits more complicated and less efficient. Similarly, transportation planners can use graph concepts when designing road systems, railway networks, and traffic routes. Reducing unnecessary crossings can improve organization and reduce confusion. Computer scientists also use crossing numbers when visualizing data structures and communication networks. Cleaner graph drawings help people interpret information more easily. To summarize, the crossing number of a graph is the smallest number of edge crossings that must remain when the graph is drawn on a plane. It helps us understand the complexity of a graph and has many applications in mathematics, engineering, and computer science. Thank you for watching, and I hope this introduction has helped you understand the crossing number of a graph. See you in the next lesson.